In the fight against the coronavirus, there is still one big unknown.
Another
How many people have
coronavirus-related
actually
death that's
contracted it?
Antibody to bring the total number of coronavirus-related.
Whoa, okay. I bet y'all have heard stories about people getting sick with the severe acute respiratory syndrome coronavirus 2, shortened to SARS-CoV-2, aka COVID-19. There has also been a lot of talks about how dangerous it is, to the point that the entire world is in lockdown. The reason there are a lot of people getting terribly sick is because their bodies do not have the resistance to this new disease. And for those who have recovered from this disease, their bodies produce something called antibodies. So, what are antibodies? A quick Google search that redirects us to a Wikipedia page tells us that an antibody, also known as immunoglobulin, is a large white-shaped protein produced mainly by plasma cells that is used by the immune system to neutralize pathogens, such as pathogenic bacteria and viruses. Basically, antibodies are the defense mechanisms of your body. They are shaped like a Y and are made out of two heavy polypeptide chains in the middle and two light polypeptide chains at its side. In this case, the heavy and light simply refers to long and short. At the top of these chains, there is a variable sign that is used to detect foreign objects such as bacteria and pathogens in our body. Every pathogen has little things that stick out of its surface. These things are called antigens and are specific to each type of pathogen. Thus, they are used as a sort of identity card. The antigen shape is also complementary to the antibody's variable binding site, so when it comes for the antibody to attack the pathogen, they can fit snugly to each other. But how exactly do they attack? Well, there are 6 ways of doing this, and it depends on the type of enemy they are at war with. The first way is for the antibodies to combine with the toxins or viruses and keep them away from the host cells of our body. When the bacteria produces toxins, antibodies will surround it and prevent them from getting near healthy cells so that they won't cause any damage. The second way is for the pathogens that have tails, such as bacteria and protists. In this case, the antibodies will attach themselves to their flagella, which is the proper name for cell tails, and prevent them from moving about. When they're at the state, it is easier for the phagocyte, a type of white blood cell, to engulf the pathogen and kill it. The third way is for antibodies that have more than one binding site, as not all of them do. In this case, the antibodies will attach to a pathogen, which is attached to more antibodies and more pathogens. They create this huge clump of germs that are slowed way down. This process of clumping up the pathogens is called agglutination. Because they're in this clump, they move about less freely, and thus there's a less chance of them going in and infecting healthy cells. Next, the fourth method is for the antibodies to punch holes in the bacteria cell wall. This will cause the bacteria to burst and its watery insides to spill out. Of course, this will cause the bacteria to die, and so no harm will be caused by it. Phagocytes, which I mentioned before to be a type of white blood cells that kill pathogens by eating them, have an antibody receptor on their cell surface membranes, which allows them to attach themselves to the heavy polypeptide chains of antibodies. So, the fifth way is for the antibodies to attach around the pathogens so that the phagocytes will detect the presence of the antibodies, attach to them, and in turn engulf the pathogens to death. The final way is less violent than the previous ways, and that is the antibodies will combine with the toxins and neutralize them so that they are harmless to the body. This type of antibody has a special name. They are called antitoxins. So that's it for this video, and I hope you've learned something about the little warriors inside yourself. Stay safe and don't go outside. This video is produced by me, Gabrielle from 10E, for the Semester 2 Biology final project. Sources for information that I use for this video, as well as clips that I used but did not make, will be linked in the video notes.